vertically downward for this body. For this body, vertically downward is this.
Sir, screen is not visible, sir.
Sir, you are not sharing the screen, sir.
See now. So if a body is present here on the surface of Earth, its weight will be acting vertically downward. That means this is the direction of weight, mg. If the same body is present here on the surface of Earth, will its weight act like this, vertically downward? This is not
No,
vertically downward
sir.
for that body. Vertically downward for this body is this direction. If the body is present here, South Pole, then will its weight act like this? No, it will act like this. If the body is present here, will its weight act like this? No, it will act like this. So in true sense, weight of a body always acts towards the center of Earth. Or you can also say that it is always vertically downward, because if a person is standing near the North Pole, he will be pulled towards the center of Earth. For him, it is vertically downward. If a person is at the equator, standing at the equator of Earth, Earth will still pull him towards the center of the Earth. For him, vertically downward direction will be this, not this. And if a person is standing at the South Pole of Earth, Earth will be pulling him towards the center of Earth. For that fellow standing at the South Pole, vertically downward direction is not this. It is still this, which is nothing but towards the center of Earth. So you can say like the direction of weight as either towards the center of Earth or vertically downward. Vertically downward is easier to represent and easier to understand also. So that's why we say weight always acts vertically downward. Vertically downward. I'm putting this under two balloons, clouds. Okay, weight. That's about weight. Next thing, normal reaction. Come to this normal reaction. What is this normal reaction? Here, normal does not mean literal normal, not normal of your English, regular. It's not that kind of normal. It's mathematical normal. Mathematical normal means perpendicular. You call a perpendicular in mathematics as normal. It is that normal here. Reaction. You know what is reaction from Newton's third law? If you give some reaction, you give some action, you will get some reaction. That reaction. So what is this? How do you get this? To understand, simple. Let us say this is a surface. Yes, this is a surface. Say this is a table. This is your table on which you are sitting right now. And on the table, you have some body. Your laptop is there, your computer is there, your bag is there, your book is there, something is there. This is a body of mass m based on the table. Okay. From our first force, which is weight, if this body has mass m, it will be having weight mg. Because Earth is pulling it down, it has weight mg. What is the direction of this mg? Downward, vertically downward. So this body of mass m is being pulled by Earth in vertically downward direction by a force mg, which is its weight. Okay. And we know from Newton's second law that wherever there is force, there will be acceleration. So here there is force. Mg is a force. Due to this force, the body should get accelerated. Accelerated means it should move. That means it should fall down. It should fall down. Does it fall down? If you place a body on a table and don't do anything to it, leave it, it will be there forever, literally, unless you do something. But from this thing, it must get accelerated and fall down. It is not falling down. It is not falling down means Is acceleration 0 or force 0?
Force.
Force is not 0 because it has mass, some definite mass, 100 gram, 200 gram, 2 kg, 4 kg, some definite mass is there. And g for every body on the surface of Earth is same, 9.8 meter per second square. So m is not 0, g is not 0. So weight cannot be 0. Weight cannot be 0. If weight is not 0, force is acting. Force is acting, the body should get accelerated. But it is not getting accelerated. What does it mean?
There
If
are
I
balanced reaction forces occurring in the opposite direction.
yes, if I imagine, if I place the same body in air and leave it, it will immediately fall down. It will immediately fall down to ground. But once you are placing it on the surface of a table, it is not falling down. Still, its weight is there. Earth is still pulling it down, but it is not falling down. This means that some other force is acting on this body, which is balancing its weight. The situation is like, if this is a body of mass m, I am applying a force of 10 Newton towards right. It should move towards right. If I apply force of 10 Newton towards left, it should move towards left. Okay. If I apply 10 Newton towards right and 10 Newton towards left, what is the net force? 0. If net force is 0, what will be acceleration? 0. It does not move. It will be stationary. If I remove this 10 Newton, it gets accelerated here. If I remove this 10 Newton, it gets accelerated here. Okay. In the same way, mg is acting on that body, but it is not getting accelerated. Means some other force must be acting on it. In which direction? In the exactly opposite direction. And what is this force doing? This force is balancing the weight. This is a reaction. Weight of the body acting on the table is action, and the table is giving this reaction. Weight is acting on table. Force. Weight is a force acting on the table. Action. So table also applies force on that body. Surface also applies force on that body. Third law, Newton's third law. You call that reaction force as normal reaction, represented by N, capital N. Or in some books, it is represented by capital R also. N is commonly used. Okay. Now imagine you suddenly pull this table aside. What happens? It will fall down. That means the moment the body loses contact with the surface, normal reaction becomes 0. If there is no normal reaction, only weight will be acting downward. And due to that weight, it will fall down. So this is normal reaction. Normal reaction. If you compare it with this body, which is held in air and left, its weight mg is acting down. There is no normal reaction because it is not in contact with any body. There is no normal reaction. There is no force to balance its weight. So it falls down. It falls down. That is the difference between, that is what you mean by normal reaction. If you are sitting on a chair, your weight is acting on the chair and chair is giving normal reaction on you. Wherever a body is stable or a body is stationary, definitely some normal reaction due to some surface will be acting on that body. Okay, normal reaction. Okay, details are there. We will note down them in our next class. But be clear with mass and weight. Okay, right. We'll continue in the next class. See you and good night.
Thank you, sir. Bye, sir. Good night, sir.
Thank you, sir. Bye, sir. Good night, sir.